येलो वाले शर्ट पे तूने लाइट वो भी उसको बॉल पे लगाया मैंने वो एसीटोन से घिसा और फिर धोया वॉशिंग मशीन में डाला so it was like gone हाँ
मैंने दिमाग में लगा तो पता भी नहीं था मुझे लग रहा मैं पूरी तरह से कर ली तेरा भी लिख
तुम्हारा है यार
बस इलेक्ट्रिसिटी और बस लिख सकती हूँ हाँ है ना इसके बाद मैग्नेटिक कंट्रोल एग्जाम में है
पता है मुझे
पता है
एक में कैसे जाता है
आज की बात मेरा भाई है
We less students. They come early. Yeah, a minute ago. Okay. Where did we stop? Last class. We're doing activities. Or
activities.
Like which activity? Activities there are so many. Like tell me the topic. Last topic was activity we completed. Did we do heating effect of current?
We are in
magnetic. So did we do force on current carrying conductors and magnetic field? Did we do Fleming's left hand rule?
Yes.
Okay. Then the next topic in a volume is not in syllabus. That is electromagnetic induction. Right? And the topics which are not in syllabus, you just strike out electromagnetic induction. Under it, you have Fleming's right hand rule. Under it, factors to increase the strength of induced current. Okay, direct and alternating current I have already told you, right? While I was talking about current, so that is more than enough. Then you have, you can just read this part: direct current, alternating current, and advantages of alternating current over direct current. Yeah, I know that. ये है ना दोनों AC DC नहीं किया क्या? You Anushka she was too absent, so you guys were present. You did not.
Yes, sir.
She did not attend electricity. I know that.
No, magnetic.
This was covered in electricity when I started current, right? So go back, refer to your notes if you take notes. So there is DC current and AC current right in the beginning of electricity. I taught this. Okay. So this part is already covered. This part is already covered. Just go through it. If you have any difficulty, you can ask me back. Now the next part is, and the last part is domestic electric circuits. Do you want me to revise this? Direct and AC current and all? Can give one request. Okay. Okay. So what is direct current?
Which goes with one direction.
Yes. So DC, as it is called, acronym. Direct current is it flows in one direction and its magnitude remains constant. So DC flows with constant magnitude. In same direction. Second, you can study it with the help of graph. Like if you plot the current and graph, so this is time in second, this is current in ampere. So it is always constant. That's why it is also called steady current. What is it called? Steady current. It does not change with time. Right? So 3-4 points you can write down. What is the source? Source of DC current is main supply. Where in your home. Mains is this. That's AC, not DC. Source, battery. Cells or batteries. Cells, battery. Or DC generator. Now, generator also we have not done. Okay, generator. Okay, so these are the key things that you should remember about DC current. Also, you cannot increase or decrease. Okay, whatever is the current in the circuit, that's all that the cell can provide. So you cannot increase it beyond the capacity of the cell. But let's look what is AC.
Basically reverse.
So as the name suggests, alternating current. Alternating in the sense, not only alternating, its magnitude constantly changes. Alternating current flows with constantly changing magnitude. Changing magnitude. And direction. As shown below. So if you plot a graph of AC current versus time, so this graph appears like this. Okay, so it varies sinusoidally. This is 0. So it alternates between positive and negative direction, and the magnitude also continuously changes. Increases, reaches a maximum value, then decreases, reaches the minimum value, again, then increases in the other direction, maximum value, then again reduces, and so on and so forth. Okay. And third, what else? What is the source of it? AC generators or AC mains, as I said. At your home, the supply is AC.
So how is the magnitude changing in the current in AC current? Only direction is changing, right?
What's this? Is the value on y-axis changing or no? Changing or no? 0, then reaches certain value, then again decreases that way. So source, AC mains and AC generator. So what's the difference between AC mains and AC generator? AC generator could be portable. You must have seen like when supply goes off. So sometimes you have AC generators running near the mobile towers. Have you seen that? Near your society or your lift generator. Any building supply goes off, then the generator that works is AC generator to power the entire building. Okay. So what are the advantages and disadvantages? Let us now cover each one. So advantages of AC over DC. So it has advantages only, first of all. The first is, suppose you write down till here then. So any idea about the supply? What are the values of, what is the source, DC source value? Generally this comes in 1.5 volt, 3 volt, 6 volt, 12 volt. Okay, this kind of a factor. So cells are available in this offerings. Whereas here, domestic supply is supply that comes to our house is 220 volts and 50 hertz. Now here how many hertz? 0. There is no cycle. There is no frequency, so 0. But here this kind of cycle, one positive, one negative makes one cycle. 50 such cycles in 1 second. Okay? So all alternating current switch 100 times, the direction 100 times in a second. Okay? So this is the frequency and this is the voltage. Domestic. Okay? This is what it is. Shall we discuss the advantages? This is one side. So 50 cycles per second. Cycles per second is hertz. Easy, you're not running around. Everybody, just read the first point for yourself. Now, this is the domestic supply. What about industrial supply? This can go in thousands and lakhs of voltages, depending upon whether it is a small industry, medium industry, large industry, okay, or heavy industry. So it can go up to lakhs of voltages. Okay. Now, first thing is, if you want to send the electric power over long distance, generally the electric power is produced thousands of kilometers away. Okay, from the users. Like we are using the electric supply in city, but where is it produced? Have you seen where electricity is produced?
In those coal factories where coal is got brand.
So where is the coal factory in Maharashtra? somewhere in Dhanbad, right? Jharkhand, Bihar, okay? Or if it is a thermal power plant, then coal is brought and then burned. Okay? So mostly the electric power generation facilities are hundreds, minimum 100 or hundreds of kilometers away from the city or the users, where users are consuming it, okay, from the consumers. So it is transmitted over power lines that you must have seen through highways and seas. Have you seen overhead power lines? So those are the power. So you cannot do that with DC supply. You require alternating current power. Okay, that's one. Second is the generation of alternating current is easier, and so is the transmission. So this is more like familiarity. Just first read everything and discuss. Let's discuss it. So too much detail is not expected, just the familiarity. Many things you'll not understand because those are topics of higher standard. Okay, shall we discuss? Shall we discuss? So first point, any difficulties? If it is long distance transmission, it has to be AC. Okay, DC power you cannot send over such long distance. The reason is mainly the losses associated, right? You have discussed heating effect of current. So whenever current is flowing across the wire, it will generate heat. I square RT. Now when the transmission cable is like hundreds and thousands kilometers long, then will its resistance also be long, resistance of the cable? So the cable will have very high resistance and current flowing through it will be lost. Almost 30 to 40% power or even more is lost just during transmission. Okay, so with DC that's like next to impossible to pass such kind of thing. This increases, decreases, so it averages out. Not only that, the voltage at which AC is generated, right? It is actually transmitted at much higher voltage than that. Okay, let's say like when it is transmitted at almost 1 lakh volt, while it is produced in the range of around thousands of volt. Some multiples, exact number is different, okay? But then how it is increased, right? So for that we use a device called transformer. So we step up. So from this, it is stepped up to thousands volt. But at our home, what supplies we need? 220. So before, if 1 lakh volt enters our house, it will burn everywhere. We don't have a device which can run at that. So we have devices to operate on 220 volt. So it has to be stepped down. So what are these? There are different kinds of transformers available. Like same transformer has two functionality. On one side it will step up, on the other side it will step down. Okay? And you are using it on a daily basis actually. So whenever you charge your mobile, what kind of device is mobile? AC or DC?
DC.
DC. Why DC?
Because it has battery.
Yes, it runs on cell, right? But battery doesn't last more than 24 hours. Then You throw the mobile after 24 hours.
No.
Charge it. So how do you charge it? What supply you have at home? And what is mobile? So what do we do now? Huh? Convert it from AC to DC. So what do you use? The mobile charger as an adapter actually. The charger that you see is a very, it's not an ordinary plug, it's a bulky plug, right? It's like bulky, okay? It has a transformer in it. Okay? So what goes inside is 220 volt. Okay? AC is what goes into it. So first AC is converted to DC. So there is one circuit which does AC to DC conversion. Once it is done DC, then it is like it is brought down also 222. So both these things are done. It is rectified to DC and it is also brought down to 5 volt to 10 volt. Mobile works on 5 to 10 volt. Okay, so from 220 it is stepped down to 5 to 10 volt DC and then it is given to mobile for charging. Okay, so this thing you are using on a daily basis, but you will realize it only when you start reading about it in higher standards. Okay, that's it. Only this is one advantage for transmission and for converting from lower to higher and higher to lower. This functionality only possible in DC. With DC you can't increase or decrease. Okay, whatever is there, it's there. Whatever the cell is designed, its rating is fixed, no flexibility. But with AC, depending upon what device you are using TV also, you are using AC also, right? Both is powered by 220, but not necessarily the same voltage is going inside. So internal, your circuits which will moderately supply power to the required power. Okay, so that is that clear? Okay. Next part is domestic electric circuits. So for that, I think I should open the notes that I have. We're already on 10. Okay. So, did we discuss all this overloading, loading and use and all? We discussed that, right? Heating effect of current.
Heating effect of current.
So, fuse was it,
Yes, sir.
So now we have this domestic electric circuits. So I already told you what circuit we use. We use basically AC power, okay, which has 220 volt as the input supply. So basically, how the power comes in our houses with the help of 3 wires. The way the electrical devices run is you have to connect it to electrical energy source with the help of wire. So there are 3 wires. So one is called line, the other is neutral. Okay. And then you have ground. It is also called as earth or ground. Everything has got two names. So like neutral, live is also called phase. Phase one. So these are the different names of the wires. Live wire, neutral wire, earth or ground wire. Okay. So how they are characterized is they are characterized with the potential. So in the live wire, you have 220 volts. Okay, it is carrying the maximum potential. Neutral is at 0, ground is also at 0 potential. So it is electric potential. What is potential? Stored energy, ability to do work. So all the energy is carried by live wire. Okay. So when you have the circuit, what do you require? How do you operate a device? You have a device, let's say electric iron. You have a device, electric iron. Okay. So what this electric iron will have is, it will have a heating element. Right? Then what comes out of iron is wire. Okay. And then you also have, so you have 3 wires actually. And this is the handle. So this is the most basic device that is used. So this wire which is connected to the body of the appliance, so that is earth wire. Okay, this is the live wire, and this is your neutral wire. Okay, so every device will have, not necessarily all devices will have 3, minimum 2, live and neutral. Every device will have, so minimum 2 wires every will have, and the high power devices, okay, which carry large current like geyser, heater, okay, they will also have earthing. Why earthing? Sometimes what happens, there is a break of insulation here in the live wire. So then it may touch the metallic part of the appliance. So that so then the metallic body also is also on live. Okay, accidentally if you touch it, let's say somebody touches it accidentally. Okay, and let's say you're standing on the ground. So then the circuit is completed through you. This live through the body will go in earth. Earth is also conductor. So you get a shock. When will you get a shock? If there is no earthing. Okay. So earthing में क्या होता है कि this earthing is already connected with ground. There is a main grounding which is already done, which is outside your meter of the society. Okay. So this is already connected to earth. So our body's resistance is higher than Earth's resistance. Earth is very good conductor as compared to us. So this current which is available in the body of the appliance will go fast to the earth other than through us. That's how we are saying. Understood? So earthing is a safety mechanism, nothing else. So what I'm trying to say is every device will have live and neutral connection, and some high power devices will also have live, neutral and earth. So some devices will require 2 connections and some will require 3. Is that clear? Which device will require 3 connections?
The devices.
The devices which require earthing also. Okay. So now let us understand it with the help of the wiring diagram. So whenever the supply enters your housing society, right, these 3 wires will be given to you by the energy company. Which company supplies us power here? MSED. Electricity bill. What electricity bill? That company name, you see that? Mostly I think it is MSED. Maharashtra State Electricity. MSED. Maharashtra. So So it is called Maharashtra State Electricity Distribution Company. This is one of the companies which is distributing. Now this may buy electric power from various energy distributors like Adani Power, Tata Power. Okay, this is only a distribution company. So you understand, one is producer, the other is distributor, and the third is consumer. So there are three people. So energy producing companies like, it could be anybody, it could be state company like BARC, that's a nuclear power, okay, NTPC, okay. So those are the government energy producing bodies. Then NTPC is National Thermal Power Corporation. So they will have coal-based power plants. So they will burn coal. BRC is doing what? Nuclear reactions. Okay? All of them, the way the electricity is produced, it gets its name from them. Then you have hydropower. So like in Punjab, wherever you have dam, Narmada dam, etc. So the electricity is produced by building dams. That's hydropower. So in Maharashtra, we have hydropower in Pune, right? Koyna Dam, etc. You must have studied. Have you heard about it? Tata Power, Karjat mein. Have you heard about Tata Power? So these are the energy producers. Then these distribution company may buy it, and then they can distribute it to our house. So it is these companies which will provide these three wires to our society. From that, then the wiring will be done in the entire building, then to a house level. So what is shown here is the wiring of the house level. Okay. So house level wiring is this. This is the wiring in one room of your house. But before that, this is the connection till the energy meter. जो तुम्हारा distribute होता है ना, every society has a meter room. So these three things are till the meter. So what wire will come? You have a earthing wire, then the live wire, and the neutral wire. Let's start from here. Okay. So first thing that is connected is a electricity board's fuse. Main connection. Like if the entire building's power is to be cut off, just this fuse will be switched off. Or if something bad happens in the society, so this fuse will blow off first, saving the entire building. Okay? Any short circuiting happens, the current or the supply will be cut off right there. Okay? So that's the main fuse. After that, you have the electricity meter. This is the society's meter. One is individual flats meter, then your society also will have a meter. Okay? So this is the society's meter, or it is just a notion for combined meter of everything. It doesn't happen like that. Okay? So imagine this is the combined meter of everybody. Then what is happening? So how many connections are there? We don't require earthing here for fuse, because this is just either will continue the circuit, keep the circuit open or closed. So we don't need, nobody is going to work here. So earthing is needed wherever you are dealing with the appliance. So nobody, only authorized personnel will enter here in the meter room. Okay, so no earthing. Same with the meter. So live, so it goes through meter and then this is how it proceeds further, right? Then this is the distribution box. In this distribution, like in your building, you have multiple floors. Each floor has various house. So you have, two lines. So you have the live connection. This is through the fuse. So every house will have a individual fuse. Okay. Can you see the splitting here? Every house has individual fuse, and then this is the neutral. Now what happens when you make a circuit? So how the circuit is completed? The power goes through live wire. This is the load, hits this up and then returns. So neutral provides a return path. This is how the circuit is complete. It should be continuous and closed path, right? So the current goes from here, okay, and then through the device it returns back. This is the circuit. Okay. Now, so now the wire actually reaches your house. From the meter room, now the wire is reaching your meter house. Likewise, in other house, the same thing can be done. Pull a red wire from here, pull another wire from here, okay? And similar circuit or setup can be made for the other house, okay? And then there is a earth wire running, so you can just pull out wires from there, just join wires, okay? You have to join.
So, but why is an earth wire used over there?
Everywhere it is required, no? In your house, earth wire has to be there, no?
Sir, but what
Where?
is the function of an earth wire?
That's what I explained. It saves you from heavy electric shock.
Yeah, I
In
got
case-
that, but like, the main function of the earth wire.
What could be more important than saving one's life? So it is to protect you from that. You probably did not understand. There There are certain appliances whose bodies are metallic. Okay? Let's say in old times the electric irons bodies were metallic. Nowadays you have fiber covering. Okay? So most of the devices now are like fibers. And you see this keyboard. So earlier it used to have an iron plate. So when you're lifting, there is a possibility that you'll get a shock if this live wire insulation is broken and it is touching the metallic part.
Yes.
So this whole body is now electrically sensitive now. So now let's say you're careless and you're barefoot, standing on the ground, and you lifted the keyboard and you get a shock right there.
Yeah.
You get it now? So has anyone got a shock in the bathroom? Anywhere? Where?
I was really young and I just like put my hands into this.
You put your hands in the socket?
Yeah.
Like both fingers? Like what? You're playing or?
I was really small, like 5, 6 years old.
Ah, okay. You're not insensitive.
I was like curiosity, a lot.
So that could be like, those experiments you won't get a second chance.
Yeah.
It's just lucky. Okay? So if it was DC, you wouldn't have survived to tell us this. DC is more lethal. AC, because it is increasing, decreasing, you get a chance to pull out. It's more safer. It's not always at its full capacity. Like DC, once it is running at its full capacity, that's it. It will do maximum job once you got in contact with it and finished. Okay, but here you have variation, so that saves you. So good. So is the purpose of Earth clear to you? So this is a schematic diagram. It is difficult to base, but what I'm trying to say is, in all devices, you see this. Either you get a 2-pin plug, like in case of a mobile adapter. So this is connecting your device, but where it is hooking into a socket. So you have two types of sockets with only 2 pin or 3 pin. So this plug you put here, the other plug you get is something like this. This kind of plug. So this has earthing also. Earthing, live, neutral. This is only live and neutral. So all the low power device, you don't require earthing. Our body is also like electrically sensitive. Okay, so we have a tolerance level. We can tolerate shock till a certain upper limit. But beyond that, we will really feel it. But beyond that, we'll go down. Okay, so it's like that. Okay, so is it clear? In our body also, the current running is in microamperes, 1 millionth of an ampere. So this TV might be running on about like half an ampere, like 500 milliampere. Okay, so this computer, etc., they are running at milliamperes. So which means they are running at current 1000 times more the current that is running in our body. So, and this is like 10 ampere or 15 ampere. These are really very high, 10, 15 ampere. Okay, so enough to kill us. These are electric iron. Wherever you see watt in excess of 1000 watts, anything in excess of 1000 watt is enough to kill us. So most of these devices, geyser, heater, these are lethal if there is no proper earthing. Okay. So the purpose is to make you aware, not to scare you. So if you work with these devices with full awareness, then it's pretty safe, right? Like the train in which we sit, at what voltage it operates? 10,000 volt to 1 lakh. Now imagine if the current leaks into the train body. Most of it is metallic, right? So there is a like the metallic portion that you are touching, but then there is an insulation in between. Okay, it's not that you are in direct contact with the supply. All those cares are being taken. So that those are design issues. Design and safety is there are guidelines which are followed. Okay? But you should be aware about it. So you should not like deliberately attempt to just see what happens. Like here, can you see this? So the lower 2.1 is live, one is neutral. This is earthing. So earthing has a bigger diameter. So you cannot miss this. These are international standards. In earthing, you cannot put live wire. In earthing, only earthing pin will enter. So those precautions are taken that you cannot make mistakes. And then it is fixed. Once you align the earthing, the other will dock into live and neutral. So these are designed at design level. Those things are taken care of.
So there are like some instruments in the hospital like they put it in our chest.
That is pro. So like if you're talking about like electrocardiogram, yes.
Yeah.
So those are sensors. So they will pick up this heart is beating, okay? So it's vibrating. So it will pick up the vibration. Now you have a healthy human, those data is with you, okay? So if it is an unhealthy guy, so heart will not beat at the same rate. So his electrocardiogram and the other normal healthy human being cardiogram, when they compare, that's why you'll know how abnormal or normal this is. Okay? So we always have the normal charts against which we compare the abnormal ones.
So like
She's getting scared.
person like alive वो लगाने के बाद
Arey Baba, so I said you're not getting 220 volt, na? It is stepped down to our tolerance limit. So electricity, that's why with AC we can do all that. You will not be fed a current which you cannot resist. Okay. Then the other thing is with radiation, like X-ray machines, etc. One is electricity, the other is radiation. Now radiation also, our body has a tolerance limit. So you should not be exposed to more radiation than what you can tolerate. That's why for X-ray, etc., you should not do frequent X-rays. X-ray is electromagnetic radiation. More can cause cancer also. So overexposure can lead to cancer. That's why we have ultrasonography devices which work on sound waves, which are less lethal. Sound wave is much lower energy wave as compared to electromagnetic wave. Okay. X-ray is lower only to gamma rays, which is the highest energy. So gamma ray you expose like history, no trace, right? So kids have to be like exposed to with some sort of scary tactics, otherwise they're very enterprising and would try to reach the wrong areas. That's why your school teachers mostly, they are not very patient in explaining. They just will scare you and shut you off. You're not allowed to touch that. Get off. ऐसे होता है ना? So very regimented discipline. So it's only for your own safety. Mostly when you're in labs, okay, listen to the lab instructor very carefully. Sometimes it's more useful than your teacher. Sometimes teachers are not practically as experienced as the lab instructor is. So every time in the lab, there will be one function responsible for managing the lab only. You should very carefully listen to what he's saying. Okay, and do not experiment unnecessarily without asking for his guidance. Okay, coming back here. So have you understood all the blocks? Okay, so now these are three devices. The sockets made like this. So these are three sockets made. So each pin is connected. One is connected to neutral, the other is to live, okay, and the other is to earthing. Now you can connect the device. Device will also have this. You just hook it here. Understood? This is how the device will draw power. So what is the potential difference between live and neutral? 220. So this is what connection? Series or parallel? Parallel. No? Each device is getting 220 volt. Correct? And then you may have a socket with only 2 pins also without earthing. That's also allowed. Is that clear? Is the logic understood? So it's just how the wires are drawn, nothing else. This is the distribution code. Like this is a society with only 3 flats. Each flat has got its own fuse. You get it? So the one is the fuse at the society level, the main fuse. Then every flat has its own fuse. The supply is shown only for one flat. And then if you have one more room, you can pull this wire further. Go on connecting. The entire connection in our house is in parallel. Okay? So take some time to read through it. This is completely theoretical, right? And then we'll take up the questions. So this is just one page. Just read through it from the textbook. You have the textbook? It is good from the textbook only. So I will just magnify this and read it. Can everybody see this text? Should I magnify it a little bit more? Okay, read this. Tell me when you are done, I will scroll it down. So live wire is also, what's the polarity of live wire? Positive. This is negative, and this has no polarity. It is new. It is normal. So the first fuse that you saw was main fuse. You can see the diagram in your volumes. Okay. So collectively these are called line wires. So the main circuit is this: live, device, and middle. That's how the circuit is complete. This is like your cell. Plus minus is like your cell, but it's actually not plus minus. It's undergoing like that. So what is changing? This is changing. This remains 0. What is changing? Live. Understood? This remains 0. And this anyway is at 0. Okay. So we'll resume further and then we'll take up questions. Read through it. I think even in your notes they have copied the same thing. Okay? Just read through the whole thing.